Welcome to your Unit 11 trig graphing review video. I'm going to scroll through and show you which highlighted problems I'm going to go through. All right, well, starting back at the top. So starting with question 1, letter A, just stating all the different information you guys need to know about trig functions for this test. Amplitude is this coefficient on the function. It's the distance from the midline of the function. So our amplitude's 3. Frequency comes from this B value right in here, which is 2, which means you would expect to see 2 full sine curves over the course of 2 pi units. Period is always calculated by 2 pi divided by the frequency, which in this problem is 2. And I'm getting pi as my frequency. So that means over pi units you would see 1 full sine curve. Or it would take pi units to see 1 curve. Now be careful when it comes to phase shift, because right now it looks like moving right pi over 2, but actually it's pi over 4. You need to make sure you factor out that B value. And when doing that, it's the same thing as multiplying by 1/2 in this case. Whoopsies. So this should be a pi over 4. Okay? Because pi over 2 times 1/2 is pi over 4. So our phase shift is pi over 4, and that means moving to the right. There is no vertical shift because there's nothing being added or subtracted here. So that means your midline is y equals 0. Maximum value is always the midline plus the amplitude, so we've got 3. Minimum value is the midline, take away the amplitude, so -3. And that's what's going to relate to your range of -3 to 3. Your domain is all reals. Alright, so that's a sine graph, and just to remind you, this is what a regular old y equals sine of x graph looks like from 0 to 2 pi. This is what a traditional cosine curve looks like from 0 to 2 pi. Now, one we didn't talk about until the very end of this unit was tangent, who looks much different than those two. We need to remember that tangent has asymptotes. Okay, and those asymptotes occur at odd multiples of pi over 2. So I'm going to pause this for a second and set up my axes. Okay, here are my axes. I'm only going to graph from 0 to 2 pi, so that's why you only see this much on the x-axis. I am going to lightly dash in the asymptotes at my odd multiples of pi over 2. So that's pi over 2 and 3 pi over 2. Now, in order to graph one tangent cycle, you're going to go halfway in between 2 of the asymptotes. Halfway to the left, so yes, you're in the middle of a box. You're going down to -1. Halfway to the right, you're going up to +1. That's because technically it's 45 degrees, and you're going to be going up to a +1, because tangent of 45 is 1. Okay, so you graph it extending toward the asymptotes. Now I still need to finish the rest of this. Technically there would be another asymptote over here at -pi over 2. Halfway in between, that would be here at 0, because tangent of 0 is 0. Halfway between the x-intercept and the asymptote is 45 degrees, which you're up at 1. Okay, and technically we've got the left half of the tangent graph over here at 2 pi. Done. And that's tangent. Now, let's say, for example, let's say that I snuck a 2 in front of here. I know this isn't a part of the review, but let's just say I did. Okay? That's not an amplitude of 2, that's a vertical stretch of 2. So what would happen is each of these 1s or negative ones would become 2's. So to adjust this accordingly, that would actually be 2 and negative 2. And let's say then if it was 3, then it would go negative 3, 0, 3, negative 3, 0, 3, and so forth. So this vertical stretch would just change these little critical points into what's equivalent to if you took each of the y values and multiplied by this leading coefficient. So it's just something to be aware of. Now typically it goes, like I graphed here, assuming this is 1 and negative 1, it always goes negative 1, 0, 1, unless there's some sort of vertical stretch in front. Alright, the next couple of problems are testing your knowledge of what's happening at cosine or sine during certain intervals. So this next problem wants me to look at y equals cosine of x. So I just quickly sketch a graph of cosine. And keep in mind that's from 0 to 2 pi. And it says on the interval of pi to 2 pi, basically what's cosine doing? So from pi to 2 pi, that's that portion of the graph. It looks like cosine is increasing. And that's the answer, increasing only. Now at pi over 2, the difference between 2 sine of x and cosine 2x is, okay, well, think about this as 2 sine of pi over 2. Pi over 2 would be here, right? So that means sine of pi over 2 is 1. See how I use the graph to help me? Pi over 2 is an x values here. My output is 1. Minus cosine of 2 times pi over 2, which would just be pi. So here's my cosine graph. That's pi. It looks like we're down at negative 1. So this would be minus negative 1. 2 plus 1 is 3. Alright, an object that weighs 2 pounds and is suspended in a liquid. When the object is depressed 3 feet from its equilibrium point, it will oscillate according to the following function, where t is the number of seconds after the object is released. How many seconds are in a period? So you need to know that period is equal to 2 pi divided by the frequency, which in this case it's going to be 9. Now, it wants it in terms of the context of the problem, so you're actually going to plug in 2 pi over 9. And this is not pi in terms of 180, this is pi in terms of a length. So I'm saying 3.141592, dot, dot, dot. Okay, so here's my calculator. Come on, calculator, come on. There we go. Whoa, 1 second. Too many calculators. Okay. Okay, so the 3 decimals is 0.698. And that would be seconds, because it was talking about oscillating in terms of seconds. Alright, the sea dragon, a pendulum ride at an amusement park, moves from its central point at rest according to the following trig function, where t represents time in seconds. What is the period and what does it mean in the context of the problem? So right now what I'm thinking is this is a sine curve that has a reflection in the x-axis, so that means it looks roughly something like that. Okay. Now, period, which is how long it would take to see one full cycle of this, is equal to 2 pi divided by the frequency. The frequency in this problem is pi over 3. Okay, now when I do heap change flip, my pi's cancel, and I get 6. In the context of the problem, that's 6 seconds. Okay, so you would expect to see one of these sine curves once every 6 seconds. So, in the context of the problem, okay, and if you need to, I mean, here's even a visual of it, and I'm not an artist. This is one of those, like, boat rides, if you've ever been to Fantasy Island, where this is its starting position above its equilibrium point, and it's swinging back, forward, back, back to center. Okay, so what you're expecting to see here is it's moving back from its equilibrium point. So I suppose it would move backwards, forwards, back to resting place. And that's happening every 6 seconds. So back, forward, back to starting position. So the way that I'll say this is every 6 seconds, the sea dragon completes one swing back and forth and returns to its starting location. All right, now on this test, you're going to have to come up with equations of graphs given just a graph. Okay, so looking at letter E, I always ask myself, okay, first impressions, what does it look like, sine or cosine? And I say it looks like sine because it looks like it's starting on the midline. Okay, other things to look at. What's the amplitude? Amplitude's the distance from the midline to a max or min, so it looks like our amplitude's 3. Frequency is how many full cycles you're seeing over the course of 2 pi units. What's nice is you already have 0 to 2 pi mapped out. Here would be one full sine curve. Here would be the next. So I would say our frequency is 2. Putting it all together, this is y equals 3 sine of 2x. And I said it was a positive 3 because it went up from the midline first. If it had gone down first, then it would be a negative 3. Now, when it comes to B, you can clearly see it's not oscillating around a midline of the y-axis or x-axis anymore. It's oscillating about a line here. So remember, it's always in between the max and min values, which appear to be 9 and 3. 9 plus 3 is 12, divided by 2 is 6. So 3, 4, 5, 6. So the midline can always be found by averaging the maximum and the minimum value. Okay, so that's your midline, which means it appears the amplitude is 3. Now, I didn't say this first, and I really should have said it, but in my head I'm thinking, okay, what does this look like after I figured out the midline? Since it's starting above the midline and not on it, that makes me think that I'm going to write this as a cosine curve. Okay, so this is going to be a cosine curve with an amplitude of 3. Now I also have to figure out frequency. How many full cycles are you seeing over the course of 2 pi units? Now what you have graphed right now is from negative 2 pi to 2 pi, which is 4 pi total units. If you have trouble thinking in terms of pi, just ask yourself what's the difference between negative 2 and positive 2. 4 total units, and then just tack on a pi to it. So I think I'm seeing one full cosine curve because I'm going from a min back down to a min. So that's one full curve over 4 pi units, which means over half the amount you're only seeing one curve. So again, or half of a curve, excuse me. So over 2 pi units, you are only seeing half of the curve, and that's why their frequency is 1/2. Okay, so we just put it all together. Y equals 3 cosine of 1/2 x. And then we also need to take into account we had a vertical shift. So I write plus 6. At J, first impressions, I'd say it's a sine curve because it's starting on the midline. My amplitude appears to be, it looks like 1. Yeah, amplitude looks like 1. Okay, over the course of 2 pi units, you're only seeing half of the graph. You expected it to continue, you'd see it finish at 4 pi. So that means our frequency is 1/2. So putting it all together, this is sine of 1/2 x. All right, now this last example, I'm going to zoom in here. My first impression is neither sine nor cosine. So, and the reason being is when you look at the y-axis, it's not starting nicely on the midline or at a maximum value. So I'm going to write this as both. Let's say I picked sine first. I'll pick a point on the midline, just like right there. I need to figure out how much I would shift to get to that point. Now, every 3 boxes is pi over 2, or 90 degrees, which means I would have to shift to the right 60 degrees, which is equal to pi over 3 units. Okay, my amplitude looks like it's 1, 2, 3. I'd say amplitude's 3. Actually, I think I miscounted that. Yep, definitely miscounted. Looks like 4. 1, 2, 3, 4. Whoopsies. Okay, amplitude looks like 4. As far as my frequency goes, I'm going to just pick out 2 maximums. So between here and here. Okay, that looks like if I move everything over 2 more boxes, that will be over the course of 2 pi units. So I would see 1 full curve. Okay, so again, I was going to write this as a sine curve first. So I would write it as y equals, if you covered up the left-hand side of this, see how it looks like it's going down first? That means I'm going to write it as a -4, taking that reflection in the midline. And then here's my phase shift that I had to do. -4 sine of x minus pi over 3. Okay, so that's in terms of sine. In terms of cosine, okay, I'll pick a maximum point. For fun, let's pick this one right here. Let's go the other direction. So that would be moving backwards. It looks like 1 box, which would be 30 degrees, or pi over 6. When you cover up the left-hand side of that point, this cosine curve is starting above the midline, so therefore it will be a positive leading coefficient. Remember we said shift it right, pi over 6. Now all of those examples I just did had an x-axis in terms of pi. What if our x-axis was in terms of a numerical value, just like 6 or 12? So I added this in, just so you know, this isn't actually in your review packet. Okay, so still need to figure out the same basics. Does it look like sine or cosine? And I would say sine. Okay, what does the amplitude look like? Amplitude is 2. Now, as far as frequency goes, frequency is in terms of 2 pi divided by the period. So how long is it taking you to see 1 full sine curve? This is 1 full sine curve, and it's taking me 12 units in order to see that. So pi over 6 in its simplest form. So therefore I can write this as 2 sine of pi over 6 x. Now something important to compare here is my b value, or my frequency, is in terms of pi over 6 when the x-axis is in terms of a numerical, just integer value. If I look at the other examples, my frequency was just a regular numerical value while my x-axis was in terms of pi. So they will never match. You're not going to have a 1/2 as a frequency and then your x-axis in terms of 1, 2, 3, 4, 5, 6. Vice versa, you're not going to have a frequency of pi over 6 and then have this in terms of pi, 2 pi, etc. So they will never match. Frequency and the x-axis will not match. So please make sure you keep that straight. Okay. So then coming over to this multiple choice in number 15, which graph represents a cosine curve with no horizontal shift, amplitude of 2, and a period of 2 pi over 3. Now, 2 pi over 3 is 120 degrees. So looking at these graphs, the first couple I'm going to get rid of are 2 and 4 because those look like sine graphs. They're starting on the midline. So now I'm between 1 and 3. Which of these looks like it takes 120 degrees to see 1 full cosine curve? Well, if you look at the first one, this is 1 full cosine curve. But pi over 3, so 180 divided by 3, is 60 degrees. So you're seeing 1 full curve in less than 120 degrees. It's not what you want. So by process of elimination, I got 3. But also, if pi is 180 degrees, it would make sense that this is 120 degrees. And that's going to match what it wants. Okay, on your test, you're going to have to do some graphing. This one has a lot going on with it. I've got a reflection in the x-axis. We've got a frequency of 2, which means our period is pi. This is going to mean right pi over 6, which according to our scale is 1 box, because that's 30 degrees. And lastly, up 1, which means the midline is now y equals 1. Okay, so here's what we're going to do. Set up our axes like we normally do. So I'm going to pause this. Okay, now according to my directions, it says graph 1 cycle and only 1 cycle. So I'm only going to graph pi units worth of this because that matches the period. And there's a couple ways you can do this. You could graph the base function first, which by base function I mean you would graph y equals -3 sine of 2x first and then move it down and over. Or you could figure out the midline and figure out your start and end values and use the pattern from there. So I'll do it both ways, or at least explain it both ways. A lot of my students tend to like doing the base function first. So that's y equals -3 sine of 2x. Okay, so that means over the course of pi units, this would be your start, this would be your end. Halfway in between, you'd be on the midline again. Now, since it's -3 sine of 2x, that means you're going to go halfway in between the first two x-intercepts down to -3, halfway between the next two up to +3. And we lightly dash this. Now, from there, I'm going to take each of those 5 major points, and yes, there has to be 5, and move them how this wants me to, essentially. So this wants me to move them up 1, and to the right, pi over 6, which would be 1 box, according to my scale. So I'm going right 1, up 1, right 1, up 1, and so forth. And that's one graph. Some of you, though, may not like doing it that way. So give me a second here. So this would still be pi. This would be pi over 2. Some of you will want to actually draw in the midline, which would be at y equals 1. And figure out your start and end values from there. Whoopsies, I must have accidentally deleted my y-axis. Okay, there we go. So normally, actually kind of already have these here. Normally you'd start here, but you're actually starting on the midline and over to the right. Your ending would be normally at pi, but you're on the midline to the right because of that phase shift. Halfway in between, you'd be on the midline again. Halfway in between, you're going to go down 3. Halfway in between, you're going to go up 3. Oopsies. And go up high enough. There we go. And this is your graph. So either way works, no matter what, you're going to come up with the same graph. The next example uses what we call sinusoidal fitting or curve fitting, where I am looking at a table of data and I'm giving you a scatter plot as well, and I want you to come up with a sine or cosine curve that models this data appropriately. Now, in order to even come up with an equation, I'm going to need the max and min values. So I look at my table, and I find that the maximum value is occurring and is 78 degrees, technically at t equals 4, or t equals 3, excuse me, and the minimum is 25. From there, I can come up with an appropriate midline, which is called D in our general form. So I've got 78 plus 25 divided by 2, which will give me 51.5. Okay, that's your midline that you're oscillating around. Using the midline, I can find the amplitude. That's always our max. Take away the midline. So 26.5. The period is how long it takes to see one cycle, and according to the problem, it says 12 hours. The room is heated and cooled in this manner every 12 hours. which means the b value is 2 pi divided by 12, or pi over 6. Okay, so right now what I have is an amplitude, a midline, and a frequency. Something else important to note is whether you're going to write this as sine or cosine. I'm going to write it as sine because I know this, or excuse me, cosine, because I know this point right here is my maximum point. And I want my cosine curve to start at the true maximum point. Okay, so that means you're basically taking a cosine curve and shifting it to the right so that it maps onto those points. How much would I need to shift over? 3 units. Okay, so therefore my equation is y equals amplitude of 26.5 cosine of, oopsies, I forgot my frequency, of pi over 6, there's my frequency, x minus 3 to correspond to that phase shift, plus 51.5. So again, this is where this all comes from. Here's my amplitude, here's my frequency, here's my phase shift, here's my midline. And I just put it all together. Now it's a positive 26.5 in front of the cosine because your midline, about in there, it's starting above the midline. All right, last couple of problems in here. I've got a tidal wave that can be modeled by the following function, where h is the height of the wave and t is time in seconds. The amplitude, be careful not to say 50. The 50 was put in the front here. Amplitude's always the coefficient on the function itself. So our amplitude is 20. Our frequency is equal to 2 pi divided by the, what I was going to say. I'm sorry. I misspoke. Frequency in the problem is pi over 12. The period is equal to 2 pi divided by the frequency. So that's 2 pi times 12 over pi, which is 24. Okay, technically 24 seconds in the context of the problem. The midline is coming from this 50, which you guys are used to seeing it at the end here, but they just moved it. Our midline is y equals 50. So that means we're oscillating about the midline of 50 with a distance at most of 20 feet. So our maximum is always calculated by the midline plus the amplitude, which would be 70. Our minimum is the midline minus the amplitude, which would be 30. Now, how much time passes between the maximum height of one wave to the next maximum height? From one max to the next max. So I guess roughly sketching here, let's pretend this is 50, or y equals 50. You gotta imagine we're looking something like this. So in order to get from one max point to the next max point, that would be the length of one period. So one period is equal to 24 seconds. Alright, so now we're going to actually graph this. So down below, I have some axes labeled. I have some axes put in for you. I'm going to make every 2 boxes worth 10, just to get it to fit. 20, 30, 40, 50. Okay, I know I'm going to be oscillating about the midline of 50, or y equals 50. Okay, and before I graph any further, I really should label my axes here. This y-axis, according to the problem, is our height in feet. So that's height of the wave. Stop it. Oh, it doesn't want me to write on this. It's getting real annoying here. Come on. Why will you not let me write? It's much more trouble than it should have been. And my y-axis is going to end up being our x-axis is going to be time in seconds. I only need 24 seconds for one cycle of this, and that's what it wants me to graph, one cycle. So I'm going to make every 3 boxes equal to 6. Okay? Now, cosine normally starts above the midline. There is no reflection here, so that means we're going to start above the midline by 20 feet. So 50 plus 20 is 70. Whoops, that's not what I selected. 70. After 24 seconds, which is 1 period, you would expect to be back up at that maximum point. Halfway in between, so at 12 seconds, you're going to be 20 below the midline, so at 30. And then halfway in between each of those, so at 6 and at 18, you'll be on the midline. And I'll label my graph h of t. That's my graph. Yay. All right, last problem here. The sky wheel is a Ferris wheel in Niagara Falls. It has a diameter of 54 meters, and the ride lasts 12 minutes for a total of 6 revolutions. It has a total of 42 gondolas that each hold 6 passengers. Assuming the height of the gondola follows a sinusoidal model, you enter the gondola at the height of 2 meters above the ground. Determine the equation in terms of cosine, which is what this is saying. Maybe helpful to draw a picture for some of you. This is a Ferris wheel. Okay, now they're saying you're getting on the gondola at the bottom at a height of 2 meters above the ground. So here's your ground. Okay. The wheel itself has a diameter of 54 meters, which means half of 54 is 27. This is where your midline would be. 27 plus that 2 at the bottom would be 29. Okay, so the amplitude is the distance from the midline to the highest or lowest point of the wheel. So our amplitude would be 27. Okay, we just said that our midline, which would be D, would be 29, because it's plus that additional 2 feet at the bottom. Now we do need to figure out our frequency, which is in terms of the period. Now, according to the problem, every 12 minutes you get 6 revolutions. So 1 revolution would be equal to 12 minutes divided by 6, which is 2. So that means every 2 minutes you're completing 1 cycle. Okay, so our frequency would be in terms of 2 pi divided by the period, which is pi. So putting it together in terms of cosine, and you'll notice I added a negative in here. That's because you're starting below the midline getting on the Ferris wheel, which is that 2 meters above the ground. So use your equation to find the height of your gondola after 11 minutes and 21 seconds, round to the nearest hundredth. So we need to convert this all to seconds because that's what, all the minutes, because that's what our function is in terms of. It said every so over many minutes this is happening. So 21 seconds divided by 60 would be 0.35 of a minute. So this is 11.35 total minutes. And all I'm going to do is plug that in for x. Now what's important is that your calculator is in terms of degrees, as where your function right now is in terms of radians. So when you plug this into your calculator, you're going to plug in 180 for pi. Okay, so I model this here. Make sure my calculator's in degree mode, and it is. Okay, so I've got negative 27 cosine of 180 times 11.35. Oopsies. Plus 29, and I've got 41.26. That's to the nearest hundredth. So you are 41.26 feet above the ground at that point. So you'd be somewhere above the midline. Okay, find the time when your gondola is first at the height of 21 meters. So that means that's going to be your y value. So I'm going to plug 21 in for y. Okay, you're going to have to solve for x. So I'm going to subtract 29 first and get negative 8. Divide it then by negative 27, which that would actually just then go positive. So 8 over 27 equals cosine of pi x. In order to undo cosine, we use inverse cos. I'm going to change pi to 180 again. So to solve for x, we just remember to divide by 180. So now I go to my calculator. Inverse cos of 8 divided by 27. Close the parentheses, divide by 180. And I got 0.40424. Those are minutes though. Keep in mind, because that's what your function was in terms of. It says round to the nearest second. So I'm going to take that answer, multiply it by 60. And I got 24 seconds. So it said round to the nearest second. And there you go.